Alright, my math friends, we are back and we're on the very last part of Chapter 4, Chapter 4.3c. We're going to graph a proportional relationship. We're finally going to get all this, bring everything together, those y's and those x's that we've been talking about, and those y over x fractions. You're going to see what the reason is for having the y and having the x. But I want you to pause right now and I need you to fill out some numbers for me. Here's our first graph I need you to fill out because we're going to do some graphing today. So I need you to put down the hours down here, the money, and put these numbers across here. I'm going up by 10 every time and I'm skipping. So I'm going 20, skip 1, 40, skip 1, 60, skip 1, 80. So do that and then number these across here. Get that done and then you can hit play and then we will move on. Okay, thanks for getting that done. Alright, now that you pause that now and you got your graph created here just like mine, now we're going to bring everything together. Here is how we're going to graph a proportional relationship. Okay, here's our first example. A cleaning company charges $45 per hour to clean. Okay, this $45, this time they're telling us the unit rate. Alright, that's how much they charge per hour. So here's our unit rate. Here's our rate of change. So what we want to do is take this $45 per hour and we're going to make that into a table. Okay, so here we have our table. So let's say if this company cleans for 1 hour, well, they're going to charge $45 for that. Okay, and let's move on to 2 hours. Let's see how much they charge. Well, 2 times 45 is going to give me 90. And after 3 hours of cleaning, 3 times 45 is going to give me 135. And after 4 hours of cleaning, we're just making some numbers in here so we can make this table. 4 times 45 is going to get me $180. That is how much they are charging us to clean. Okay? And if we were going to turn this into our y over x fractions, y over x, remember we got to decide which one of these is the y, which one of these is the x out of these categories over here. Okay, x is the thing that doesn't change, y is the thing that can change. So looking at this, hours does not change, but the amount of money being charged can change depending on which company you use to clean or any other factors. So here's our x and here's our y. We're not going to set up our y over x fractions because we already know that these would come out to 45 because we just did the math and we were told that they were going to be 45. But what we do need to do, what we use this for, we have the x and we have the y. Take a look at our graph down here. Remember graphing coordinates? Yesterday we said this line along the horizontal is x and this line over here is going to be y, our vertical line. Take a look at it. It matches what we just did in this table. Our y, these numbers here, is the money, which we already called that y, and x, the x-axis down here, this is our number of hours. And this is why we had to go through all the x and the y stuff earlier in the chapter, because these are actually coordinates that we are going to graph. Okay, these numbers, these puppies that go together, we're going to graph these. So for example, remember when we graph, it is the x coordinate and then the y coordinate. So if I was going to graph this first set of numbers, I would put a point at 1 and 45. And like this next set of numbers, it would be x and then y. So this one would be 2 and 90. Okay, so each one of these are points that we are going to graph, and that's exactly what we're going to do. We're going to graph this first one. We're going to put a point at 1 and 45. So here we have 1 hour, and this company charges $45. We don't have a 45, so we will just put a dot right there. 2 hours, if you look at the table, the company charges $90. So we'll put that right there. After 3 hours, this company will charge $135. We are right here really close to 140. And after 4 hours, this company will charge $180. Okay, so we can graph this proportional relationship, and when we do that, take a look what happens. I need to grab my ruler over here, and if you have a ruler or a straight edge, do the same. I want you to connect these points, because when we connect them, there's some interesting things that happen that I want to talk to you about. So we are going to graph these, and we're going to see what happens. Okay, there's my line. I got my ruler up here. You can't see my ruler, but trust me, it is there, because nothing makes me happier than a nice straight line. Alright? Well, a few things do, but in this case, let's just say it's the straight line. Alright? So we made our straight line, and look what is going on. A proportional relationship is always going to have the same things in common when you graph it. Okay, here's what it's going to have in common. First of all, it's always going to start right here at 0. Your line will always go through 0 when you connect the dots. So what makes a graph proportional? Well, it starts at 0. Okay, and 0, that's called the origin. Alright, that's the fancy word to say the start of the graph, okay, is the origin. And another thing that, we'll call this number 1, the second thing that makes a graph proportional is it always makes a nice straight line, okay, straight line. That's the second thing that makes a proportional relationship when we graph it. Alright, and what would we use this line for? Well, we could actually make some predictions with it. Like if we wanted to know how much the company would charge in 5 hours, we could go up here and we could continue our numbers, and we'd be able to find out what that charge would be at 5 hours. Okay, that's the nice thing about a graph. And if we wanted to write the equation for this proportional relationship, remember it is y equals k times x. K is going to be the unit rate. We already know the unit rate is 45, so this would be y equals 45 times x. And if you take a look at what is happening in the graph, every hour we're going up by $45. So from 1 hour to 2 hours, that's another $45. 2 hours to 3 hours, 45, and so on. Okay, that's where our equation fits in, is that each point is $45 away from the second point as we keep climbing. Alright? Kinda neat, isn't it? Well, even if you don't think so, I think it is. Let's take a look at some other examples. Okay, I have another one for you. Pause this, go ahead and write these, label these and put these numbers down. This is just counting by ones. This is counting by fives, but I'm not labeling the 5. I'm just skipping 1, going by 10, skipping, going up another 10. So label that, and then check back in with me, and we'll graph this situation when you are done. Alright, my math friends, thanks for getting that labeled. Let's take a look at this situation. We are going to graph this proportional relationship. Speedy Bikes, this is a company. They assemble 15 bikes per hour. This is our unit rate. We're being told what it is this time, so that saves us some steps. We don't have to calculate it. We want to make a table and a graph to show this proportional relationship. Okay, so let's just start getting some numbers here. Let's say 1 hours. We can make 15 bikes in this situation. 2 hours, 2 times 15 is going to get me, yikes, I almost wrote down 15. 2 times 15 is going to get me 30. After 3 hours, 3 times 15, 45. And after 4 hours, that's going to give me 60 bikes. Okay, so we just created a table showing how many bikes could be assembled. Now we need to decide which one of these is our X and which one of these is our Y. Well, the hours that cannot change, the hours stay the same. We can't change time, alright? But the number of bikes that can be made in an hour can change depending on what company you have or what people you're using to assemble the bikes. So this is a number that can change, all right? And that matches what we have going on here. The number of bikes is this number right here, and that is our y-axis. And then down here we have our hours. This is our x-axis. Now we can go ahead and graph these points, because remember, these are actually coordinates that we can graph, like this first two numbers here, 1 and 15, that would be our coordinate. Our second numbers here, we could have 2 and 30. We're just having x and y so that we can graph them. So let's put these points on our graph. After 1 hour, speedy bikes can make 15 bikes. After 2 hours, they make 30 bikes. I'm just going off the numbers on our table up there. After 3 hours, 45 bikes. 4 hours, we're up to 60 bikes. Okay? Now I want to connect these together using a ruler so I can make a nice straight line, and you will see that this is going to make a proportional relationship, because first of all, it is going to go through 0. Alright, our line is going through 0. And it is also straight. Yes, it is. Oh my gosh, I missed a part of the line. Give me a second. Wait for it. There we go. Yes, we got it. Okay, good. We have our straight line. It does start at 0. So this is a proportional relationship because of what this line makes. And if we wanted to write the equation for this proportional relationship, we are already told that the unit rate is 15 bikes per hour. So we would write y equals 15 times x. That would be our equation. And it matches our graph because every point goes up by 15, alright, which is good. And if we wanted to find out how many bikes could be made in 5 hours, we could actually continue these numbers and see what that would come out to. Okay? So there's our graph for that. There's our situation. Let's take a look at something else we're going to look at for this last part of the chapter. I'm going to have you write down this information about this graph too, because we're going to actually just look at the graph now and decide what the unit rate and equation is going to be for this graph just by looking at it. Okay, so here we have rainfall during a storm. Okay, this line and these points show how much it rained during a storm. We have hours and we have inches. So go ahead and copy that down, pause this, and then we will get back to explaining this problem. Alright, now that you have that written down, let me talk about what we are going to do. We need to find the unit rate for this proportional relationship. Okay, it is proportional. It starts at 0. It makes a straight line. Alright, and then we're going to actually write the equation for this. Okay, so looking at this proportional relationship, we can look at the equation and find it by looking at our x and y. Remember, this is our y and this is our x. Okay, so x is going to be hours, y is going to be inches, and remember our nice friend, the y over x fraction. Okay, we're going to use that to discover what the unit rate is, and we're going to take a look at our coordinates. Now let's take a look at our first point that we have here. At this first point, my x is 1 and my y is 2. So if I'm going to make a fraction for my first point, it's going to be y over x, so I'm going to have 2 over 1, okay, because this point is y is 2, x is 1, and we know that that's going to come out to 2. And let's just check a couple of these others to see if they will also come out to 2. So let's take a look at this one right here. This one is at 4 and 8. Alright, so my y is 8, my x is 4, so y over x, so that would be y is 8 over 4 is my x. Again, we're looking at this point, 4 and 8. That comes out to 2. Okay, each one of these, if we wanted to test each one of them, they would come out to 2 if we set up these fractions for all of them. Okay, 2 is going to be our unit rate. So in this graph, if someone asked, well, how much rain was falling, you could say, well, the rain was falling at 2 inches per hour. And then what would be the equation for that? Well, it would be y equals the unit rate, which is 2, times x. Okay, because each one of these goes up by 2 numbers every single time. Alright? That's how you would find an equation and unit rate if you're just looking at the graph.